Welcome to lecture number 26 of GE 103. So this is the last class of structure and unions. So in this class today we'll discuss about the concept of union first, and then we'll discuss about the size of structures and union. Okay, so what is union? I'll not write any separate program for example program for union. You read it from this book. I'll just explain it from here. Union is this almost same as structure. Only difference is inside the union, instead of structure, if this is a union, then if there are multiple members here, then only one member you can use. It means that the memory that will allocate for all the members is common. It's not separate. If you know about when we have discussed the structure, if instead of union, if it is a structure and there are three members like M, X, and C, then memory will be allocated separately for all of these members. Like M has separate memory, then X will have separate memory, and then C will have separate memory. But this is not the case in union. In union there will be only one memory allocated to all of them. So what does this means? It means that you can only use one of the member at a time. You cannot use two members at a time. For example, this union, if you use a variable, for example, if you go here, you can see code is a variable of type union, right? Because if you remember how to define, how to declare a variable of structure, the same thing will be applied here. So union item code. So it means code is a variable of union. So if I write code dot m equal to 50, and then if I write code dot x equal to 60, then the value of m will be override with x. I'll write, let me open notepad and show you the concept. What I am trying to say here, code is a variable of union. So if I write code dot x equal to 50, okay, and then next line if I write code dot m equal to 40, then the moment you write this line, the value of x, this member, will be overwritten here. Why overwritten? Because all this x, m, and c has a common memory. The memory is not separate. Memory is the same memory they are used by all these three members. So if you use one of the member, then another member will be overwritten. So maybe a question you may ask, that how it is possible that they are using a common memory, because the size of the memory requirement is not same, because integer needs 4 byte, float needs 4 byte, but character needs only 1 byte. So actually the memory allocation will be the maximum memory required for a particular member, like this. See, the maximum memory will be allocated to this, which is required for X, then it is required for M, and this is required for character. All right, so this is the concept of union. What I'm expecting from your side is read the concept of union from this book and try to understand it. Also, try to write some program of union. And one more important question. This is also a part of an assignment. Yes, I repeat every time that the assignment that I give, it's not a graded assignment. You don't need to submit it. This is just for your uh, knowledge and for your preparation for this NSEM exam. So the assignment that I am giving here to you is try to find out the difference between structure and union. Not just difference, when to use structure, when to use union, which is the scenario when using a union is better than a structure. That you have to find out and try to understand it. Okay, so the concept of union is over. Then the last concept that we'll discuss today is size of structures. It looks very simple, but not, it's a little bit complicated, so we have to understand it from the basic. What I'll try to show you a program. I'll try to show you a program. This program, it is not written by me. This program is copied from Geeks for Geeks. From this is the same program that I have copied. So you can also go to geeksforgeeks.com, and you can see this page. And this page is very in this page they have explained this concept, this size of structure in detail. You can try to understand the concept from here. So before starting this example, just let me remind you that a character is required 1 byte, short integer requires 2 byte, integer requires 4 byte, and double requires 8 byte. All these things are, I think you know all these things. So what I am here, if you see, what will be the size of this structure, means if any variable of this structure, what will be the size? And if you go for this structure, what should be the size here? If we go for any variable of this type, for example, if I go here like type def structure tag is, so if I defined struc ta underscore t and I write variable one. So this is a variable of structure A. Why structure A? I'm considering this is structure A. It is written also here in comment line is structure A. So suppose this is structure A and v1 is a variable of type structure A. So if I write here printf percent %d size of v1, what do you think what it should print? Or simply if I say that what is the size of v1, size of v1 means it's same as from the beginning of this course, what I am saying that the moment you declare a variable, instead of this if I write integer x, the moment you write this line, the moment you define a variable here like this, it means that a memory will be allocated for this x, right? In compute in the memory of computer, a location will be allocated for this variable that I am explaining from the beginning of this course. But how many the size of this location will be 4 bytes here because this is an integer. So in memory 4 bytes will be reserved for this variable after after writing this line. So for same thing here in this line, if we go for this you are also declaring a variable here of type structure. So after this line, the line number 1, a memory will be allocated for this v1. So what should be the size of that memory? So if you go to structure and if you try to calculate here, you will say that, okay, sir, character, this structure has two members. So character need 1 byte and sort integer needs 2 bytes. So 1 plus 2, 3 bytes required for this structure, right? You will say 3 bytes, but it's not three and three. If you run this code, it will say this is taking 4 bytes. The code is already, let me run this code for you, then you will understand. If I run this code, I think, yeah. See, there are four structure here: structure A, structure B, structure C, structure D. So the first line is printing the size of structure A. So if you see, instead of three, it is saying four. Let us go to the second structure. If you go to second structure, then what should be the size of each variable of this structure? This is the question. So each variable of this structure is, if you calculate it like this, sort integer takes 2, this is 1, character 1, and this is 4. So 2 plus 1, 2 plus 1, 3 plus 4, it should be 7, but see, it is 8. So there is even more surprise in this. If you go for this, then and in the same question, if I ask that any variable of this structure C, then how many memory will be allocated to that variable? Here if you see, this is 1 byte, double takes 8 bytes, so 8 plus 1 9, and then 4, it should be 13, but see, size is 24. And see, in the similar fashion, if you go for structure D, this is the structure D, there are three members, then this should take 8 plus 4 12 plus 1 13, but again it is taking 16. So why this difference? And in fact, if you see these two structure, the internal members are same, just they are reordered. See, character was in last, now character C is in first, double D was here in first, double D is in middle, but an integer is last. So the members are also same, thus they are reordered the members. So why there is a difference? Why if every variable of structure is not taking the exact size? So that's why calculating size of structure is a little bit tricky and you have to understand it. So to understand the size of how to calculate the size of structure, I have to understand 3 points. The 3 points are written here. I'm explaining it from here so that you can also open this page if you want, and you can read it directly from here. There are three things you have to understand: what is called alignment, padding, and data packing. Three things. So before going for alignment and packing, let me explain you some basic concept. These basic concept I have already explained. I think in lecture 2 or lecture 1 I've explained when I said that if memory is a byte addressable memory. If you remember, I have explained you that byte addressable memory means suppose your memory looks like this. If we consider memory look like this, every byte has a address. This is address 1, address 2, address 3, address 4, like this, right? Memory is the byte addressable memory. But another thing I have mentioned that time, that computer follows von Neumann architecture. Von Neumann architecture means every time if you need to process something, you have to go to memory and collect the data, right? So every time when the processor request for a data, it's not request for a single byte, it's request for a combination of bytes, and that is called word. Every time whenever the computer goes and request for a data, it will request for a word. It's a combination of bytes, normally 4 bytes in a 32-bit machine, and sometimes it's 8 bytes for 64-bit machine. But let us consider that's 4 byte. So every time whenever your processor requests for a data, it's a word. It will request for a word, and the word is a 4 byte data. So instead of arranging your memory in this way, that's a byte 1, byte 2, byte 3, actually you can arrange it, assume that it is arranged in this fashion. There are 4 banks, so each row here means one from here, one from here, one from bank this, and one from here. So this is a row. Each row is a word, assume each row is a word, and every time when your computer request something, it will read a particular row. If it's read this row, then it will read one particular word. If it reads this row, then it will read another particular word. Okay. So now if you are if you have a data yeah, and you have stored the data in such a way that half of the data is stored in row 1 and another half of the data is stored in row 2, then how you will read it? I'm again repeating my question, try to understand it. If you want to read a data, or if you want to read a word, and the how this data is stored in memory, half of the data is stored here in row 1, and half of the data is stored here in row 2, actually in this format. Then how you'll read? To read this data, you have to read 2 words, and 2 words means it's a time consuming process. You will every time that also I think I have explained in my initial classes, that processor is very fast, but the memory, if you compare RAM, hard disk, cache, they are means actually the memory components are slower than the processor. Okay. So if we go for multi means instead of one, if we go for two time, we have to go and access the memory, then it's a time consuming process. So if you can store the data in a single row, you can store the data somehow, you can single row, then computer can go and read the entire data at a time. So that's why alignment is important, and that is called alignment. So you have to understand that for alignment thing, what they do, that character can be aligned from any place. Character is not important. Short integer should always start, means if you want to store a short integer variable inside a structure, then it's always start from from multiple of 2. Means you can either store it at uh, you can either store it from this position or this position. You should not start a short from here, because it's not a multiple of 2 location. Because if location is 0, suppose this is 1 2 3 4, suppose. So so this is 1 2 3 4 like this, so it should be multiple of 2 every time when from where you are storing a short. And the same thing for integer. Integer should start from multiple of 4. Means any location from where you are storing, the starting location should be multiple of 4. That is called alignment. And if it is a double, then it should be from multiple of 8. If it is double, then it should be multiple of 8. So these things you have to remember. This is called alignment. And padding means that, for example, padding I will explain. I'll explain padding with this. I think I should explain padding with the first. Let me copy it to Notepad so that I can open both these and this both. Okay, this is a structure. Only important thing is the two member here. So first member is character. So how many bytes it will take? It will take 1 byte. So you can start it from any location. So and every time I suppose I'll start from this. I'll try to store it from here. So everything is blank, so I'll start it from here. Okay. So here character will store 1 byte. Next one is short integer. Short integer alignment is it should start from multiple of 2. Can we start short integer from here? No. As I have said previously, that short integer alignment should start from multiple of 2. So you if first is fine character, so you have stored character here, so you cannot store short from here because this is alignment will match not match, so you have to start storing short from here. It will take 2 byte, so it will take 2 byte means this byte, this byte and this byte, these 2 byte will take by this member function s, and this will become unused, so that is called padding. So this padding will be added inserted in the structure variable. So this byte will be used, so the entire, so the size of this structure will be 4 byte not 3. Actually it's look 3 that 1 byte here and 2 bytes here, but since 1 byte, this 1 byte will be reserved for c, and this and the because of alignment of short you cannot allocate s from here, you have to allocate s from here, so total will be 4. That's why it was showing 4. Now let us go to the next structure and let me explain you why it is not showing, why it is showing 8. Okay, so try to understand it why it should show 8. Actually it's no need to save. Let us go and try to relate to this. First is short, so if I start from here it will take 2 byte, that is fine, 2 byte. Next is character c, no problem, character c can alignment any from any position. So 1 and 2, these two position are for short for s, and this will be for character c, this is for c, that is fine. But next is third one is integer. Integer should start from multiple of 4, so it cannot start from here, integer can only start from here, right? So integer will start from here, so this will become a padding, so we have to left it. That's why 1 2, this 2 for short, this is for character, and this will remain blank, this will remain blank, and then I will store from here this entire 4 bytes, 1 byte, 2 byte, 3 byte and 4 byte. This 4 byte will be given to I. So that's why these two row will be required to for each variable of this structure. So that's why the size here is 8. If you go here you can check size of this structure v is 8. And now let me go to this one, this is even more interesting. Then if I try to relate this one, why this is showing 24, what you can do here, maybe you can pause my video here and try to understand that why this every variable of this structure will take 24 bytes. Actually it should look it's looking like this, it should take 13 bytes, right? 13 bytes means 1 plus 8 double is 8, so 9, and then 4 here 9 plus 4, it should take 13, but it is taking 24. Why? Character c, so first is will start from this location 1 1 byte. Then next is double, double alignment is 8, right? Alignment is 8, so if sorry, if the alignment of double is 8, then double can either start from here or from this location. And if you can see this character is taking this first location, so if character is taking this location, then double cannot start from any of this location, these and all this location, because alignment that it should start from multiple of 8. So if one double is starting from here, next double will start from third row, right? So here character will be assigned to this location. Then remaining 7 bits, 1 2 3 4 5 6 7, this will left as blank, so this will be called padding. So we'll add this empty bytes here, and then double d will start from here, and it will take 8 bytes, 1 2 3 4 5 6 7 8. Okay, and then integer s will take how many bytes? Integer s will take 4 more bytes. 4 more bytes when it will start from 1 2 3 4. So in this case how many bytes is it is taking? Here it is taking 8 byte, here it is taking 8 byte. 8 plus 8 plus 4, 16, right? But why it is showing 24? 16 is clear. First of all, you should understand that why it is showing 16. Actually, it is not 16, it is 24, but at least you should, sorry, 20, not 16. Here, 8, 8, 8 plus 8 plus 4. 20 should be clear to you. Now I'll explain why it is taking 4 extra. But if 20 is not clear, then again you have to check what I have said. Just go revise my whatever I said 5 minutes before and try to understand why the total should be 20 here. Okay, it is 20, but why extra? Why extra 4? Because size of this is 24, not 20. This is because normally what happen, there is a double here, right? Double D. So normally what happen, if we go for multiple variable, if you suppose you have declare a type def is here na? So instead of writing all complicated thing, write student. Suppose this is my type def as I have shown in previous uh, lectures. So student, suppose A10, I have, what is this? Student A10, let me maximize it. I think now you can understand. This is a structure, type def is written here, and this is a structure, and it is written student. So now student A10. Now A is a area of structure, and how many variables are there? 10 variables are there. So here what will happen? A0 will suppose A0 will start from location 0. Suppose, okay. So A0 will start from location 0, or you can say location 1. So how many bytes it is taking? It is taking 20 bytes, okay, according to this calculation. So the next one, A1, will start from 21. Will start from 21. So this is not, it is not maintaining the alignments. So that's why if there is any double in your member, so what happened that it should maintain that the next variable should start from a multiple of 8. Next variable or the next bottom location should be started multiple of 8. So what will happen in this particular variable, at the end of this all the memory, they will make sure that the next variable should start from the multiple of 8. So what is happening here? Here it is taking 8 bytes, here it is taking 8 bytes, but this integer will only take 4 bytes. So it may be possible that next variable may start from 21. So they want to avoid it. So that's why what they will do, they will add 4 more bytes to this particular variable. So here a8 plus 8 16 plus 4 20 plus 4 will be 24, and that is called, uh, here it is written, it is called data packing. So why means why I'll advise you to read this piece completely. You'll understand it in much better way as compared to the book. Also though in and book also the same things are written, but I'll say that this example is better. This page is better to understand it. Okay, so I hope it is clear. So now let us move to the last structure, structure D. If you go for this particular structure, then what should be the size? Last one, D is 8. Double D will start from it is in past, so it will start from first location. So we can assume that this is the multiple alignment is matching. Okay, 8 byte, and integer C will take how many bytes? 4 byte. And then character C, character C will take 1 byte, right? So if I compare this, then I think again I have to copy it, otherwise it will be difficult, because this diagram is important to understand it. And let me copy it here. Okay, now double D means it will start from here, first line, and first row and second row will be reserved for D, because 8 bytes are required. And then start from third row. The third row is completely required for S, because 4 bytes are required. 1 2 3 4. Third row is completely allocated for S. And then character C, character C will take 1 byte from fourth row, 1 byte from fourth row. But actually it should stop here, but it will not stop here. It will take all this. Why all this? Because it should assume that the next variable should start from multiple of 8. So if it should assure that you want to assure that its next variable should start from multiple of 8, then this is taking 8, then here it is taking 4, and this should take, instead of 1 it will take 4. So 8 plus 4 plus 4, so it is 16. So in this way they are assuming, they are assuring that next variable should start from the multiple of 8. Okay, so if you go here, you can see that size of last one is this, size of this is 16, this is 24. So you can see that if you when you are designing a structure, it is very important that how you are writing the member variables. If you write members in this format, see, then the members are same, but if you write in this way, then size will be taken as 24, but if you write in this format, then size will be as 16. You can also change the size in I think if I sometime, okay, wait. So actually, you should declare the members inside the structure in either increasing or decreasing order of their bytes required. For example, here this require 1 byte, this required 8 byte, and this require 4 bytes. So either you should write like C, S, and D, or D, S, C. Means either increasing order or decreasing order. If you follow in these two order, then the number size of the structure will be minimum. Always remember this. Okay, so what I have explained today, I have first explained union, and then I have explained you the concept of how to calculate the size of a particular structure. And for this I have advised you to read this page. What you can do, you can just search this thing, structure, member alignment, padding, and data packing in Google. You will get that automatically. You'll find this particular page of gigs per gigs. So they read from here, and you can also search this gigs for other concept also. This is a very good website, I hope you already know, right? So you can just click any of these and you will find a lot of new concept about C programming which is not written in your textbook, and also which is not covered in in this course. Okay. Now let us run some other program for the same. So here, what do you think? If I run this code, what will be the output? Actually, what I'm doing here, try to understand the code. This is main, so this is not required. I'm hiding all this thing. Try to understand this line from here, line number 8 to line number 21. And what will be the output of this code? I'm deleting all this thing. You try to guess the output. Integer, 4 byte. Basically, it is trying to print the size of each variable. See, structure A. Structure A, the size of this structure I'm trying to print. So integer X, 4 byte, then double. So after 4 byte, next double alignment is multiplication of 8, right? So after 4, immediately you cannot start allocate Z. So there should be a padding of 4. So 4 for X, and plus 4 as a padding after X, and then double will start. So 8 plus 8, so 16. 16 is here, and then sort can start from after 16. Sort can start because sort alignment is multiplication of 2. So after 16, sort will start immediately. So 8 plus 8, 16 plus 2, it should be 18, but it is not 18. It will again show 24. Why? Because of this, after this variable, after this one structure variable, the next structure variable should start from multiplication of 8, right? Which is written here as data packing. Read it, you will understand it, why it is saying data packing. Okay, so based on this, what will happen that after here 4 will go for 4 bytes of padding. So 8 plus 8, 16, plus 2, 18, and plus 6 bytes of padding after this. So total size will be 24. So let me run this code for you. You will understand that. See, it is showing size of structure is 24. Okay, so if I resize it like this, double should go up, then integer, then what will be the size here? 8. Then immediately you can start 4, and then you can write this. So and then there will be two padding. So here 8, 4, 12, and then after 12 it will take 2 bytes, and after 2 bytes it will go for two paddings, and the total size will be 16, not 24. If you run it, this was 16. So see, this should be the best way to locate memories here. And I think this program I have explained you, and these are the programs that have this program is from your previous classes. So here there is a array, right? It is not a not a integer, not a means inbuilt data type. It's the array. So if there is a array, so you have to check which array it is. It's the array of characters. So character array can start from any location. There is no, the alignment will be same alignment will be, should be maintained here. The alignment, if it is a integer array of integer, then alignment of integer should be maintained. If it is a array of double, then alignment of double should be maintained. The remaining thing is, so you can start printing the size of this. This is very tricky if you want to print the size of this structure. Then because if you want to calculate the size of this structure, then this addr is another structure. So first of all, you have to calculate the size of addr, this structure, and then this structure. So you can calculate manually. I always, if you write the code here and if you run, then obviously it will give you the correct output. But what I am saying to you that don't run the program, just you can pause this screen here, and what you can do, you can calculate the size of this structure. Try to calculate it in manually. If you can do this, then I'll assume that you have understood the concept, so how to calculate the size of a structure. Okay, so this chapter is also done. I have explained all the concept of structure. You have to understand the base this chapter very properly, because the concept of the structure is very important when you want to write a data structure code. Whatever data structure you go for, either linked list, tag, queue, circular linked list, tree, or for all these things, structure is very important. And also, as I said, if you want to maintain some data if you want to maintain some real life data in a computer, and you want to do something with this data in C programming, then you have to go for array of structure. As that I have explained you, right? Array of structure means it's by array of structure you can store a table of data. I have explained all these things, so that's why this chapter is very important. There is no basic concept here, but what we have done here is most of the basic concept the concept that we already know from the previous chapter. We have used all this concept here in this chapter, but the concept that we understand in this chapter is very important for future programs, specific, especially for data structure programs. So you have to understand this concept very properly. Okay, so I'm stopping this lecture here. The next lecture will I'll discuss about a very interesting thing, that if instead of one file, if you have multiple files, then how to compile your code and all. That will be discussed in next class. Thank you.